All right, so I kind of left you hanging right there in the last video. I said we're talking about a mole. So in chemistry, what is a mole? All right, very important topic to discuss. In chemistry, we use the molar mass, and that's a way of representing how we can compare periodic table masses, atomic masses, which is in AMUs, to grams. So 1 mole of anything is equal to that mass in grams of your AMUs. So for example, lead, like we just saw earlier, has a 207 AMU atomic mass, okay? It's off the periodic table. If we have 207 grams of lead, then you have 1 mole of lead, okay? If we have water, water has an 18 AMU formula mass, again, because it's a formula, it's a compound. So if we have 18 grams of water, then we have 1 mole of water. So 1 mole of anything is the mass in grams of your AMUs, all right? Copper was 63.5 grams would be 1 mole, okay? People get a little confused sometimes when they hear that, you know, you have 1 mole of something and it can be different amount of grams. Well, just know that it's a way of representing our periodic table in terms of grams. So now if I say 1 mole of something, 1 mole of lead, go weigh it. Well, 1 mole of lead, you would weigh 207 grams on your scale, and you're in good shape. You're massive, okay? So there's a couple examples. The way that we often represent it as well is 18 grams per mole. This is the unit for molar mass. Molar mass is grams per mole. So if I ask for formula mass or atomic mass, really I'm looking for AMUs, but molar mass, the label or unit should be in grams per mole. Okay? So there's your initial stages of our mole. Okay? Now, what we're also going to take a look at is moles and particles. And moles and particles, again, is dealing, the analogy I use is like a dozen of something. So if you have a dozen of something, 1 dozen, you have 12. If you have 1 dozen eggs, 12 eggs. 1 dozen cars in the parking lot, there's 12 cars in the parking lot. 1 dozen crayons, 12 crayons. So we can represent a mole as an amount of particles. 1 mole of anything is 6.02 times 10 to the 23rd particles. We're going to look at how big of a number that is times 10 to the 23rd, but again, writing this as a regular number would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 20, in essence, 21 zeros after the 6.02. Or 602, 21 zeros, a ridiculously large number. And again, we'll take a look at it as how really large this number is in a second. But 1 mole of anything is that many particles, all right? So that could be atoms, molecules, or formula, ionic compounds, which is formula units. This stands for formula units, okay? So if you have an atom, then you could have 1 mole of something. So notice this is an atom right here. Lead is an atom off the periodic table. If you have 1 mole of it, you have 6.02 times 10 to the 23rd atoms. If you have water, water is a molecule. 1 mole, and again, the abbreviation is interesting. We just dropped the E, but 1 mole of it is 6.02 times 10 to the 23rd molecules, because water is a molecule. And salt, for example, whoops, see if I can go back. Salt is an ionic compound, and so since it's an ionic compound, it's a formula unit, and the abbreviation, you could use U. A lot of books might use U. FU is fine. Formula units. I'm going to tell you, I pretty much will use molecules and formula units together. Notice there is a difference between an atom. An atom would be something just alone. But notice if we have compounds, I might make the mistake and say we have 6.02 times 10 to the 23rd molecules of NaCl. That's not correct. An ionic compound is not considered a molecule. It's considered an ionic compound. It's considered a formula unit. So, but for my purposes, again, just realizing that it's a compound is good to recognize. All right, so again, 6.02 times 10 to the 23rd particles, and whatever that particle could be, one of these three, atoms, molecules, or formula units, is 1 mole. All right?